Rover 110. Get ready. Get set. Go!
Trine students worked for 9 months, traveled 600 miles, and in the first 30 feet of the course,
All right.
Here we go.
the drivetrain failed. Half the competition gone, just like that. But they weren't giving up. This is the story of how Trine University's rover team nearly didn't make it, and what it took just to get to the starting line. For 31 years, NASA's Human Exploration Rover Challenge has pushed students to help humanity expand its reach in space, designing, building, and racing a human-powered rover over terrain that simulates what astronauts will face on the Moon, and eventually, Mars. Trine's team consists of 8 seniors, all majoring in design engineering technology, beginning with Alan Jones, our team lead.
So I'm the NASA HERC team lead, which means I get direct communication with the HERC team from NASA. All the emails and such go to me. And then I was assigned to the wheels as a sub-problem initially.
Our pilots for the competition are Bailey Bravata from Holland, Michigan, and Dominic Skinner from Brownsburg, Indiana. They'll be the 2 operators of the vehicle in Alabama for the competition. We also have Braden Duncan from Pendleton, Indiana, Evan Sosinski from Carmel, Indiana, Grace Captain from Bluffton, Indiana, Kevin Sorensen from Royal Oak, Michigan, and Juan Arroyo from right here at home in Angola, Indiana.
My name is Juan Arroyo. My role in this project is I am helping with the fabrication of the actual rover, as well as I kind of do a lot of stuff in the background of the project. The reason why I got into design engineering itself was because I love building things and creating things. Engineers can take what we imagine and actually make it come to reality. Being able to take what we just made on a 3D model and bringing it into an actual physical thing is probably the most exhilarating thing that I would say.
I'm actually one of the pilots that's going to be on the course for the competition. So I'm sitting in the front seat, so we've used me for measurements, making sure that I have enough room to pedal all the way. My height and size, we're trying to win the competition, so fitting me in that tiny space, you got to think about that. I think the team was just kind of in agreement. We honestly didn't even really think about it. We were like, yeah, you'll be the pilot. So that was fun.
This challenge started back when Artemis became a thing, NASA's Artemis program, which was trying to solve the problem of putting a human-powered buggy on the Moon for exploration.
We have to build a human-powered rover that can traverse a half-mile course within 8 minutes. Now, within this course, there are obstacles, roughly about 10 obstacles that we have to traverse.
One of the most important requirements is the 5 foot by 5 foot by 5 foot storage capacity. So obviously we can't fit 2 people in a 5 foot space pedaling, so we have a telescoping frame to allow it to extend to 8 feet, and then it can be collapsed down to 5 foot, so it fits that requirement for NASA.
The 8-minute time limit that we get is kind of in hints to the 8-minute limit that you have on oxygen.
Biggest goals that we had compared to last year was, one, we want to be underweight considerably from what they had.
Our frame this year is actually aluminum, where last year's was steel, so theirs was super duper heavy.
Right now we're estimated to be around the 135 to 175 weight range. Part of the criteria of the competition is to be able to finish the course within 8 minutes, and we really want to be able to achieve that, which is why we went with a lighter weight and a more simplistic design. And then the last thing is we just want to be able to say that we built a more efficient rover than last year.
Hi, this is Dominic Skinner. I was calling about a request for our material because I was told it was going to be ready for pickup today, or yesterday or today, but I haven't gotten a confirmation yet.
Is it under your name?
Trine University. It's the NASA rover.
The team and I underwent a lot of different research. The first step of the process that we took was to split it into sub-problems, because building the whole rover as one move would be more difficult than divvying up the best solution for the sub-problems.
How are we going to steer the rover? How are we going to power the rover in this case? driving it, what are the main criteria that we're looking for in our rover.
Jenkins wanted us to just come up with as many ideas as we possibly could, no matter how crazy. He was like, no is not, it's not the time for no right now.
Professor Jenkins, he's actually the sponsor of our project. I've had Dr. Jenkins in class through most of my time here. His main help with this project specifically is that he's done this several times. It's just simply wisdom and experience for us. Not to mention he's a very well-versed engineer. So he gives us a lot of tips and tricks and kind of helps to ease the load because the HERC team demands a lot on the early stages so they can ensure that the team will be ready for the competition when it comes. And that's a bit of stress on the team, but Dr. Jenkins has been a great help to kind of ease that load and just give us tips and tricks and kind of nudge us in the right direction. He's letting us make the decisions and come up with our design concepts, but when we need help, he's always readily available.
This is your seat here, little bucket seat. Then you have your brakes system here, and your steering is what we're thinking going to be kind of like almost a zero-turn steering with two handles. With brake control, just normal bike brakes.
Per requirements of NASA, it has to be a foot off of the ground. And then if needed, we can add little bars here, but that's not the goal because it's not as stable, but if we have to, we can.
It's well known in this competition that a certain drivetrain system called a pinion gear system is very efficient, and it's almost always put in place on those rovers that take first. The problem is one of those systems costs $1,000, so we've been doing our best to work around that budget constraint so we're not blowing everything, and we kind of have some leeway for problems that may arise second semester when build starts.
The drivetrain here would be two separate pedals connected. The two separate pedals would run chains to a single axle that would rotate the pinion and then in turn rotate the rear wheels because this would be simply rear wheel driven. With all of our material, most of the fasteners and estimated costs of wheels and other things as such, it comes out to be just about $2,000.
We gave that presentation to the faculty and got more feedback, and then we decided on a final design concept.
They were able to help critique the options that we created and helping us narrow down to a better and sufficient design, which is how we ultimately landed on the design we have now.
Now we start 3D modeling and assembly.
You gotta be right against the backstop. You have to get this away from your guts or your guts splay out on the floor. Okay? Start the blade while lifting. So your shoulders should kind of absorb some weight. Start the blade and nice and easy.
There's a lot of different rules and regulations to actually constructing the rover. The primary being that you're not allowed to use almost any pre-constructed parts. So almost everything that you use on the rover has to be designed and constructed by the team.
We have all the drawings that we need done, we have the modeling done, we have the proposal done. It's now coming to the last half, which is the more important half, and that's the actual construction of the build. I feel like for whatever reason, we might have overlooked something and it won't come up until it comes through the building side of the actual rover, so that's my only concern. Now, do I think we'd be able to achieve and correct those concerns throughout the time? Yes, I do think we would be able to do that once we're in that building phase.
I genuinely think that we all have a level head and an equal mind in the idea that we want to do well in this challenge. We have the goal of getting third or better overall, which is pretty difficult, to be honest, but we're a dedicated group.